Okay, let's have a talk about scale and distortions in photos. This is fairly important information, so we'll get straight into it. Okay, at what we call the principal point of a photograph, you're directly above the features in that photograph, such as trees, buildings, whatever else. To illustrate that, have a look at this image. The principal point is a dead centre of the photo, and you'll see that this tall building, all you can see of it is the top. Whereas as you go away from the principal point, you'll see that the buildings lean out from that centre progressively more and more towards the edge, leaning to the left on the left of the photo, to the right on the right of the photo, upwards to the top of the photo, and downwards, or north and south, if that's the orientation. Distortion increases the further away from the principal point that you move as well. Partially because of this effect, but also because any tilting of the plane and such is magnified, and I'll go on to explain that in a moment. Okay, where an aircraft is flying straight and level, you can have distortions through the height of the ground. Where an aircraft tilts, you can have distortions through the actual motion of the aircraft, as well as the shape of the ground. If you're in this particular aircraft at this point, an object viewed from the plane will be 100 units of distance, say 100 metres for example, or 10 kilometres, or whatever it happens to be. At this point it's going to be 120, which is 20% further away, so correspondingly it's going to be 20% smaller. Therefore the scale on the ground here will be a 20% smaller scale than the scale over at this side, simply through the tilt of the aircraft. Now, even when the aircraft is flying vertically and not swinging around in the air, you can have a greater distance to a point on the ground on one side of the image than you can on another side of the image. You might find that this one's 104 units, this is 107, this little peak might be, 100. So the scale will vary slightly at every point on the ground from the plane. You'll find that there are some points that have the same scale. For example, top of this peak and this little point here might be the same distance from the photo centre, so they'll be the same scale. But even in this case, the scale variation on one side to the other is only about the order of 3%. So bear in mind that scale variations can be quite marked through the motions of the plane or through the shape of the landform. If you have a landform of deep chasms and high hills, you'll get large scale variations across the photo, and it will mean that you have to reposition the images a lot to maintain a stereo pair, and it will tend to strain your eyes a fair bit. Okay, as I've indicated, ground surface and aircraft related. This is an example of the same image actually overprinted at two different scales. You'll see that this is the outline of the edge of where the pasture area meets the forestry, and this is the same photo but just printed at a slightly larger scale, and you can appreciate that there's less distortion over here than there is over here, so this is more aligned. The stereo model is closer to alignment over here than it is on this side. So you'll have to move the photos around quite a lot in this case. This is a massive overstatement of what the scale variations usually are, but in order to form a 3D image you'll have to move these areas to match up here, which will bring this into alignment here. This will probably be a bit out, so you'll then have to move it probably in this direction to get in alignment. So bear in mind that where you do have the scale variations, you'll have to be subject to moving the photos around quite a great deal. So that's a brief indication of air photos and some of the problems with scale and such. Just very briefly, talk about where we're going to head from here. This is generally in the API training courses. This is what we move on to cover. We talk about stereoscopes, which are the tools we use to view the imagery in 3D. We give a stereo vision test to participants in the course. This is an optical test which uses a specially printed image and polarising glasses to assess your stereoscopic ability. Most people get 100% in this test. We'll also teach you about the attributes of air photos, things like colour, shape, texture, etc. This is very, very important, and the way you describe what you see in the imagery should include these terms. You should understand these terms and what they can tell you, and describe things accordingly so that you can have a rigorous support basis to your description of the photos. We'll also teach you about things like attributes of photos in terms of things like juxtaposition of different features in the photos, shapes and patterns and attributes, association. For example, this has two distinct land uses in this image, and they're probably not associated at all with each other, whereas a lot of features in close juxtaposition in photos do actually help define an overall land use, because they do actually relate to each other. Just move on, and finally do some exercises to develop your skills. That's where we have a variety of different photo data sets, and we have exercises to find on using the information in those data sets to build up your ability to recognise different attributes, to describe them and report on them. And we'll talk about, in the last part of this course, we'll talk about digital airborne imagery, in particular the ADS-40 sensor, and how that differs from frame-based aerial photography, and some of the products that we can produce from that, and the specifics of the digital airborne imagery that you should know about to make adequate use of it. Here endeth the lesson. So later on we might go on to talk about some of the more in-depth information with the use of stereoscopes and some OH&S issues that you should be made aware of.